Okay students, so in the previous class we have discussed what is probability, what is event and what is sample space. But here event is nothing but the chance of happening of an event. Now this event is classified into two types as mutually exclusive events and mutually independent events. So what is this mutually exclusive events? By definition it is chance of happening of one event does not disturb the chance for the happening of another event here. Right? So here if we consider that I'm just standing here and I'm tossing a coin with one hand. So if I toss a coin, definitely I will get head or tail. So suppose I am getting head, that means automatically it disturbs the chance for getting tail here. But simultaneously if I am tossing the coins with these two hands, right? So with this hand I am getting head and with this hand I am getting tail. That means nowhere these two are interrelated. But when an experiment is conducted for only one time and I am getting only head, so it automatically disturbs the chance for getting tail. And if I am getting tail, it automatically disturbs the chance for getting head. So that means here, this head and tail are mutually exclusive. When there is a chance of getting head, tail is not getting, and when there is a chance of getting tail, head is not getting. So the chance of happening of one event disturbs the chance for the happening of another event. Then those two events are said to be mutually exclusive events. If I consider A and B as two mutually exclusive events, then probability of A union B is given as probability of A plus probability of B, and probability of A intersection B is given as 0. For better understanding, you can consider the example of our college entrance, right? So our college entrance has two gates here. So generally we open only one door of the gate here when the people are coming by walking or when they are passing by two-wheelers. Right? Then there is no chance of opening the other door of the gate. Then in this case we say that the two doors are mutually exclusive here. Right? But when a four-wheeler is coming through the gate, right, then we have to open the two doors of the gate. That means here without those two doors the four-wheeler cannot pass through in. Right? So there we say that those two doors are mutually independent. That means the chance of happening of one event does not disturb the chance for the happening of another event. That is the independent events here. Right? So with these hands I am tossing two coins simultaneously. Here I got a head, here I got a tail. No problem. Here also I can get a head and with this hand also I get a head. Right? Then the chance of happening of one event does not disturb the chance for the happening of another event. Then those two events are said to be mutually independent events. For the same example, if I consider A and B as two independent events, then probability of A union B is given as probability of A plus probability of B minus probability of A intersection B. And probability of A intersection B is given as probability of A into probability of B. So you have to remember these types of events and the formulas here. Right? So we discuss only about the mutually exclusive and independent events in this syllabus. Of course, there are other events also, equally likely and exhaustive events. Right? But mutually exclusive and independent events plays an important role for this syllabus. Then next comes the conditional probability. So what is this conditional probability? The definition is there in the name itself, conditional. Means to the happening of one event, there may be some one condition. So if you see the example here, right, you see that the clouds are there and some rain is coming. If I consider the clouds as one event and the raining as another event. So when it will rain? When the clouds has occurred on the sky. When we say that, similarly we used to say that today it will definitely rain. How we will say that? When the sky is fully cloudy, then only we can say that definitely today it will rain. So clouds has occurred. That means one event is completed. Right? Then the second event takes place, that is the rain has started. So here conditional probability is given by probability of A given B and probability of B given A. But this probability of A given B is given by the formula here, probability of A intersection B by probability of B. That means whatever is there in the denominator, right? So that event has to be completed, and whatever is there in the numerator, that event has to take place. It has to start. Right? And also we can define probability of B given A, that is probability of A intersection B by probability of A. So A has completed and B has to start here. Right? And using this multiplication theorem, we can use this multiplication theorem also using the conditional probability formula. Probability of A intersection B is given by probability of A into probability of B given A, provided probability of A is greater than 0. That means the arbitrary event. And probability of B into probability of A given B, provided the probability of B is greater than 0. right? So remember, always for conditional probability, whatever is there in the denominator, right? So that event is completed, and whatever is there in the numerator, that event has to start. Okay, now why this conditional probability is introduced? Just to find out the posterior probabilities, we have to use this conditional probability. So what is this posterior probability? A statistician Bayesian has introduced the Bayes theorem based on the mutually exclusive events and the arbitrary event, and also considering this conditional probability. So if I consider E1, E2, so on En as n mutually exclusive events, such that probability of Ei is not equal to 0, and A is any arbitrary event, the sudden occurrence of the experiment, and also A is a subset of union of Ei, then we have to just prove that probability of Ei given A is equal to probability of Ei into probability of A given Ei by summation of I equal to 1 to n probability of Ei into probability of A given Ei. So this summation of probability of A given Ei into probability of Ei is known as the total probability. Again here, if you clearly observe, we have used the formula of probability only. That is total number of chances and number of favorable chances. So here the Bayes theorem is probability of Ei given A equal to number of favorable chances by total number of chances. So while solving the problems, you can clearly understand this formula here, right? Then again we have to remember some important formulas here for solving the problems, to just detect the noise in the signal and everything, right? So I think you are all very familiar with this formula. Probability of B bar is nothing but 1 minus probability of B, where probability of B is chance of happening the event, and probability of B bar is nothing but chance of not happening the event. So instead of B bar, you can also use probability of B complement. Then probability of A intersection B. So probability of A intersection B is nothing but probability of A into probability of B when the two events A and B are independent. But when A and B are mutually exclusive, it is equal to 0, right? But when A and B are any events here, we have to also find probability of A intersection B bar. So using De Morgan's law, whatever you have learned in your intermediate, right? So using the De Morgan's law, probability of A intersection B bar is given by the formula probability of A minus probability of A intersection B. So this can be proven by considering the sample space, the Venn diagram, right? Then the next formula is probability of A bar intersection B, which is given by probability of B minus probability of A intersection B, and probability of A bar union B bar. It is given by two formulas, that is probability of A union B, A intersection B whole bar, or also we can simply calculate it as 1 minus probability of A intersection B. Then probability of A bar union B bar is also given by probability of A bar plus probability of B minus probability of A intersection B. So these are the important formulas you have to remember to solve the problems, right? Then let us consider a simple example which we have solved in your schooling also. What is the probability for a leap year to have 52 Mondays and 53 Sundays? So leap year means generally everyone know that it is 366 days, which is equal to 52 weeks plus 2 days extra. So those 2 days can be a combination of 2 days of the week, that is Sunday, Saturday, right? Or Saturday, Friday, anything, right? So if you clearly see here the combination Monday, Tuesday, Tuesday, Wednesday, Wednesday, Thursday, Thursday, Friday, Friday, Saturday, and Saturday, Sunday. These are the combinations of those 2 extra days here. But here what they are asking to find the probability that it has 52 Mondays and 53 Sundays. Definitely you will get 52 Mondays, 52 Tuesdays, Wednesdays, so on Sundays, right? But what is the condition to get 53 Sunday? Right? So here it is clearly mentioned that 52 Mondays, that means the Monday cannot be repeated here. The 53rd cannot be Monday, right? So it can't be a combination of Monday and Sunday. So we have to consider the Saturday and Sunday combination out of the 7 available chances. So by definition it is 1 by 7. So favorable chance is only Saturday and Sunday, and total number of chances of those 2 extra days are 7. Then the next problem, right? It is given that probability of A is 0.35, probability of B is 0.4, and probability of A intersection B is 0.4, right? Then find probability of A union B, probability of A bar intersection B, and probability of A intersection B bar, and probability of A bar union B bar. And also we have to verify whether A and B are independent or not, right? So This using the formulas just we have discussed in the previous